Our next problem, again, we're going to remove the largest possible common factor of 12x to the fifth plus 20x to the fourth plus 8x cubed, or to the third power. So again, what you're going to do is compare 12, 20, and 8. What's the largest number that divides into all three of those? And that would be 4. Now, each term has the variable x. How many do we take out? We take out the one with the smallest exponent, which in this case is 3. So our greatest common factor is 4x to the third. Next, we divide this out of each term. So the first term, we have 12x to the fifth. So we start by dividing 12 by 4, and that gives us 3. Here we had 5 factors of x. We took out 3, so that would leave us with 2 factors of x. For the next term, we have 20x to the fourth. So we have positive 20 divided by 4 is positive 5. We had 4 factors of x. We took out 3, so that leaves us 1 factor of x. Our last term, we have positive 8 divided by 4 is positive 2. We had 3 factors of x. We took out 3 factors of x, so no x remains. So our final answer would be 4x cubed times the quantity 3x squared plus 5x plus 2. Our next problem, again, we're factoring out the greatest common factor. We have 5x, and inside parentheses, we have a plus 9b minus, in parentheses, a plus 9b. What I'd always recommend, if there's no factors shown, it's understood in this case to be a 1 or a minus 1 in front of the minus in a plus 9b. So when we're removing the greatest common factor, remember, it's a factor. That's something being multiplied that's common in both terms. So when we look at this problem, you should notice that a plus 9b is common to both terms. So that's our greatest common factor. So in this case, we're going to take out our greatest common factor, which is a plus 9b. And now we have parentheses, and we divide that out of each term. So when we have 5x times the quantity a plus 9b divided by a plus 9b, what happens is the a plus 9b reduces, and that just leaves us with 5x. In the second, we do the exact same thing. So our greatest common factor is a plus 9b. So when we divide this term by a plus 9b, that would leave us with a minus 1, and that would be your final answer. So our next example, we're factoring a polynomial with 4 terms. Anytime we have 4 terms in this class, what we're going to do is a process called factoring by grouping. So we're going to incorporate what we just talked about in the previous 4 examples into factoring this polynomial. So when we factor by grouping, what we're going to do is put the first 2 terms inside parentheses together. And then we're going to group the second 2 terms inside parentheses together. Notice I brought the sign inside. So next step is I'm going to remove the greatest common factor of each of these groups individually. So I'm going to compare x cubed plus 4x squared. So the only thing that divides into the 1 in front of the x cubed and the 4 is 1. But you notice that both of these terms have an x. So I'll take out an x, and remember, you take out the one with the smallest exponent. So I'm taking out an x squared. So now when I'm factoring out, I had 3 x's. I took out 2, so that leaves me 1x. For the second term, I didn't factor out anything that would go into the positive 4, so that remains positive 4. I had 2 factors of x, and I took out 2 factors of x, so no x is left. So when I factored out the greatest common factor, it leaves me x squared times the quantity x plus 4. So in the next group, I compare positive 5 and positive 20. Now, a rule of thumb that we're going to use is whatever this sign is what we're going to factor out. So in this case, we're going to factor out a positive, and the greatest common factor of 5 and 20 is 5. The first term has an x, but the second one doesn't, so I can't take out an x. So what I'm going to do is divide each term by positive 5. So the first term, when I divide by positive 5, that would just leave me an x. In the second term, I'm dividing positive 20 by positive 5, and that gives me a positive 4. Now notice, what we have in parentheses is exactly the same. If you're doing this process right, it will always be the same, signs and values. So now we're going to finish this problem by doing what we did in the last example. We look inside and notice that our greatest common factor is x plus 4. And when we factor it out of the first term, it's going to leave us an x squared. And when we factor it out of the second term, it's going to leave us a positive 5. So our final answer would be x plus 4 times x squared plus 5. Next example. Again, we have 4 terms. So anytime we have 4 terms, we're going to factor by grouping. So what I'm going to do is put parentheses around my 2x minus 6 and parentheses around the plus 7xy minus 21y. So in my first group, the only thing that divides into 2x and minus 6 is a 2. So I factor out a 2, and 2x divided by 2 is x. Negative 6 divided by 2 is a minus 3. In my second group, again, since this is a positive in front of the 7xy, I'm going to factor out a positive. The greatest common factor of 7 and 21 is 7. Only the first term has an x, so I can't take out an x, but both terms have a y, so I can take out a y. Now I divide it out of each term. So if I have 7xy divided by 7y, that leaves me an x. And when I divide negative 21 by positive 7, that gives me a minus 3. I had one factor of y, took that out, so there's no y left. And again, very important, they both have x minus 3 left inside parentheses. That's how you know you're all right. So now our last step is to remove our greatest common factor, which is x minus 3. When we divide that out of each term, we're always going to be left with what's on the outside of the parentheses. So in this case, 2 plus 7y. Our next problems deal with factoring trinomials. And something about these that I'm going to talk about more in a minute is that if you look in front of the x squared, all of these only have 1, the number 1 in front of the x squared. So it's 1x squared plus 4x plus 3. It's 1x squared minus 7x minus 8. And that's going to be important because there's going to be a shortcut to factoring these problems. But let's talk about the process of factoring before we talk about any shortcuts. So we're going to talk about a process called the AC method of factoring, or sometimes referred to as the reverse FOIL method. So why is it called that? Because when we have the standard form of a polynomial, we have ax squared plus bx plus c. So we're going to be talking about the value in front of the x squared, and we're going to be talking about the constant or the value in front of our third term. So let's talk about the process. So the first step in all factoring problems, not just these, but in all factoring problems, is to remove the GCF. Whether they tell you to in the instructions or not, you're looking for a value that divides into all the terms. After we remove the GCF, if we're dealing with a trinomial, 3 terms, which we are in this case, we're going to use the AC method. So let's talk about what we do in the AC method. We're going to take the leading coefficient, and we're going to multiply it. So the leading coefficient, remember, is that a, the value in front of the x squared. And we're going to multiply it times the coefficient of the last term, which in this case we're calling C. Okay, so in this case, I'm multiplying 1 times 3, and I get a positive 3. My next step is to write all the possible combinations of the answer to step 3. So to get a positive 3, I could have multiplied positive 1 times positive 3, or negative 1 times negative 3. Okay, I'm going to choose the factors that add to the middle term. So in this case, positive 1 plus 3 is positive 4. Negative 1 plus negative 3 is negative 4. The two that add up to my middle term, which is a positive 4, is positive 1 and positive 3. So my next step is to rewrite the middle term using those factors. So I'm going to rewrite this as x squared. Order doesn't make a difference. Plus 1x plus 3x plus 3. Notice my x squared stays the same and my plus 3 stays the same. All I've done is rewritten positive 4x as 1x plus 3x. I chose those because that met the criteria. In other words, positive 1 times positive 3 gives me positive 3. And positive 1 plus 3 gives me the positive 4. Okay, notice what I have. I have 4 terms. So what did we just do in the prior examples? Anytime you have 4 terms, you're going to factor by grouping. So in this case, we're going to put parentheses around the x squared and 1x. And we're going to put parentheses around the positive 3x plus 3. So in the first group, x goes into both. So when I take out an x, that leaves me an x plus 1. When I look at my second grouping, remember sign, I'm going to take the positive 3 divides into both, and that gives me x plus 1. Again, these have to be identical. Since they are, that's my common factor. And my other factor are the 2 values on the outside of the parentheses. So my final answer is x plus 1 times x plus 3. Order doesn't make a difference. If you wrote x plus 3 times x plus 1, it's the same thing. Okay, so let's look at the next problem. Follow the steps. So again, first step in factoring is to remove the GCF. Nothing divides into x squared minus 7x and minus 8. So after I've done that, I'm going to use the AC method of factoring. So I'm going to take my leading coefficient, which is 1, times the coefficient of my last term, which is negative 8. So 1 times negative 8 equals negative 8. Next, I'm going to write the possible combinations. So to get a negative 8, it's 1 times negative 8, negative 1 times 8, 2 times negative 4, and negative 2 times 4. So those are all the possibilities. Now I'm going to add these together. The first one would give me a negative 7. The second one would give me a positive 7. The third would give me a negative 2. And the last one would give me a positive 2. So I'm going to choose the factors that add to give me the middle term. My middle term is a negative 7. So I'm going to choose the positive 1 and the negative 8. Next, I'm going to rewrite the middle term using these factors. So it's going to be x squared plus 1x minus 8x minus 8. Next, I factor by grouping. So I'm going to group the first two together and the last two together, sign and all. So in the first group, x goes into both x squared and 1x. When I take out the x, that leaves me an x plus 1. In the second group, remember, this is a minus 8x. So I'm going to take out a negative, and the value that goes into negative 8 and negative 8 is negative 8. Keep in mind, I'm dividing by a negative, so the signs are going to change. So negative 8x divided by negative 8 is just x, and a negative 8 divided by a negative 8, a negative divided by a negative is a positive. Notice again, what's inside parentheses, exactly the same. That's our greatest common factor. And the values on the outside will be what's left when we divide that out of each. So our final answer would be x plus 1 times x minus 8. Our next problem. Step number 1 is to remove the greatest common factor. Nothing divides evenly into 1x squared, negative 3x, and positive 1. So we go to our next step, which is to use the AC method. So I'm going to take my leading coefficient, which is 1, times the coefficient of my last term, which is 1. So I multiply 1 times 1. It gives me 1. Next, I'm going to write all the combinations to get a positive 1. So I can get that by multiplying 1 times 1 or negative 1 times negative 1. So next, I'm going to see which of these two add to give me the middle term. So 1 plus 1 is 2. Negative 1 plus negative 1 is negative 2. Okay, so now there's a problem. Neither one of these two add to give me a negative 3. If that happens, then that means this polynomial is not factorable. Or we call it prime. Okay, now let's get into ones where our leading coefficient isn't 1. So the steps are still going to be the same. I'm going to look to see if anything divides into all of my terms. So I would be removing the greatest common factor. In this case, nothing divides into 5, negative 33, and negative 14. There's no common factor. So that means I'm going to take my 5 times my negative 14, and that's going to give me a negative 70. Okay, so you're going to write down the factors of negative 70, or you can kind of make it simpler if you want. So I'll start by writing some of these down. I'm not going to write them all down. 1 and negative 70, negative 1 and 70, 2 and negative 35, negative 2 and 35, and then you'd go to 5 and 14, etc. But I could stop here, and you can stop anywhere that you see the answer. So in other words, when I look at the first two, that would give me negative 69. When I add them, negative 1 and 70 is 69. 2 plus negative 35 is negative 33. So that's the pair that I'm going to use. So let's go back to the AC method. So the next thing I do is rewrite. So this is 5x squared plus 2x minus 35x minus 14. So remember, when you're rewriting, The first term stays the same. The last term stays the same. All you do is use the two factors from over here that add to give you the middle term. Next, you factor by grouping. So I group the first two together and the last two together. In the first group, nothing divides into 5 and 2, but both terms have an x. So I'm going to take out an x, and when I do that, that's going to leave me 5x plus 2. For the second group, remember, since there's a negative in front of the 35, I'm going to factor out a negative. And the greatest common factor of 35 and 14 is 7. So when I take out a -7, remember, since I'm dividing by a negative, it's going to change the signs. So -35 divided by -7 is +5, and I still have my x. And -14 divided by -7 is +2. Notice again, this will always be the same. That's your greatest common factor. So when I take out my 5x plus 2, that's going to leave me with x minus 7. This may look easy or it may look difficult for some. In either case, practice will make it perfect, and you'll need this for the next module. So make sure you spend ample time practicing. So let's look at the next example. So 3x squared plus 8x minus 3. So our first step in all factoring problems is to remove the greatest common factor. Nothing divides into all three of these. So next, I go to my AC method. So I multiply 3 times -3, and that gives me -9. So I'm going to write the factors of -9. And then I'm going to add the factors together and choose the pair that adds to my middle term. My middle term's a +8, so I'm going to use -1 and +9. So I have 3x squared minus 1x plus 9x minus 3. Factor by grouping. In the first group, nothing divides into 3 and 1. So I look at my variables. They both have an x, so I can take out an x. And when I do that, that leaves me 3x minus 1. For my second group, since this is a positive in front of the 9x, I'm going to factor out a positive. And the greatest common factor of 9 and 3 is 3. And I'm going to divide that. So positive 9x divided by 3 is positive 3x. -3 divided by a positive 3 is a -1. Again, what I have in parentheses is identical. That's my greatest common factor. Once I divide my greatest common factor out of each, it will leave me with an x plus 3. Keep in mind again, you can always check your answer by using the FOIL method. So let's discuss the next concept of factoring, which is using patterns. We're going to talk about the difference of squares, the sum and difference of cubes. And so let's look at the difference of squares first. So it's important to keep in mind the words difference. Means whenever we're discussing the difference of squares, the problem is a subtraction problem. Or you need to be able to express the expression as a subtraction problem. So that's the difference. If it's not a subtraction problem, then we can't use this to factor. Squares. What are squares? Squares, when we're discussing this particular topic, refers to some value that was multiplied times itself to give you an answer. So in other words, when I look at 2 times 2, that equals 4. So 4 is a perfect square because we got 4 by multiplying a value times itself. X times x is x squared. So x squared is also a perfect square because we multiplied x times itself to give us that product. So when we're identifying the difference of two squares, it needs to be the subtraction of two perfect squares, similar to the x squared and 4. So once we've identified it as a difference of two squares, in order to factor it, we break it down into the value that was multiplied times itself. So a times a gave us the a squared. And our second terms would be the value that gave us the second term, the b squared. So that's b times b. Notice again, since it's a subtraction problem, one of the factors has to be positive and the other has to be negative. So let's look at the first example, x squared minus 9. Is this the difference of two squares? So it met the first criteria that it's a subtraction problem. And also we know that x squared is a perfect square because x times x gives us x squared. And 9 is a perfect square because 3 times 3 gives us 9. Before we get into the factoring, remember that anytime we are asked to factor, our first step is to remove the greatest common factor. So in some cases, when you first look at the problem, they may not be perfect squares. That may be because we need to remove the greatest common factor first. So in this case, again, nothing divides into x squared and 9. We've already identified it as the difference because of it being a subtraction problem. And x squared and 9 are both perfect squared. So now we just go directly into the factoring. So how do we get an x squared? We get an x squared by multiplying x times x. How do we get a 9? We multiply 3 times 3. In order for the product to be a minus 9 or a negative 9, one of our factors has to be positive and the other negative. Remember, order doesn't make a difference. So the next problem, 64x squared minus 1. What we're going to look for first is see if anything divides evenly into 64x squared and minus 1. Nothing does. So now we see a subtraction problem. So that meets the criteria of being the difference. 64 is a perfect square as well as x squared. And 1 is a perfect square because we can get that by multiplying 1 times 1. So again, we go directly into our factoring. We know that 8x times 8x gives us 64x squared. We know that 1 times 1 gives us 1. And we know one factor has to be positive and the other factor negative. So our next example, we have x squared plus 4. The first thing we look for is the greatest common factor. Nothing divides evenly into x squared and positive 4. So now we know that x squared is a perfect square and 4 is a perfect square, but it's separated by a plus sign. Therefore, it is not the difference of squares. It doesn't meet the criteria. Since we couldn't take out any value, there's no greatest common factor with the exception of 1. So that means this is not factorable. Or again, we call it prime. The next example, 50x squared minus 18. So our first step in all factoring problems is to remove the greatest common factor. We know they're both even numbers, so we know that 2 can go into both of these values. So when we factor out a 2, 50 divided by 2 is 25, so we get 25x squared. And negative 18 divided by 2 is a minus 9. Now, we test this to see if it meets the criteria for the difference of squares. First of all, it is the difference. It is a subtraction problem. We know that 25x squared is a perfect square. That's 5x times 5x. And we also know that 9 is a perfect square, 3 times 3. So we're going to write down our greatest common factor, which was 2. And now we're going to follow the pattern to factor the difference of two squares. So we know 5x times 5x gives us the 25x squared. We know 3 times 3 gives us 9. We know one of our factors has to be positive and the other negative. The next concept we're going to discuss is factoring the sum of cubes and the difference of cubes. So sum, S-U-M, refers to addition. So that means we can use this when we're adding perfect cubes. And it also has difference of cubes as a possibility. And so it doesn't make a difference if it's a plus or a minus sign separating. So the whole thing behind this is being able to recognize the sum and difference of cubes. So if we can identify it, then we're just going to follow the pattern. So what I'm going to do is look at a problem and show you how the pattern works. So here we have x cubed plus 64. What's my clue that this would be the difference of cubes and not having to worry about squares? Well, 64 is a perfect square, but if you pay attention to the exponent, this exponent is 3. When the exponent is 3, that means cube. So what we're looking for here is what multiplied times itself 3 times gives us these particular terms. So our first step, since this is the sum of cubes, we're going to use the first formula. Notice it starts as a cubed plus b cubed. So what we're going to do is break it down into the values that were cubed that give us those particular terms. So this is x cubed, because we know x times x times x gives us x cubed. And 64 is 4 cubed, because 4 times 4 is 16, times 4 is 64. Okay, so now we've done step number 1, and that's to identify what cubed gives us each one of these particular terms. Now notice, we're going to label these A and B just to follow the formula. So I'm going to put an A above the X and a B above the 4 so that you can follow the formula. So once we've identified what cubed gives us each term, we can go to our first factor, and that's this binomial, these two terms that are in parentheses. And what it says to do is take A plus B. Well, we just found A to be X and B to be 4. So again, just following the formula, whatever's inside parentheses in your first step are your A and B. And so that makes up your first factor. Notice that I have a plus between the X and the 4. That's because my original problem was the sum. Next, I follow the pattern to write my trinomial. So if you look inside the formula, that first term in the trinomial is a squared. So what I would recommend is coming back to your a, which in this case is the x, and multiplying it times itself. Instead of saying squaring it, just say this a value times itself. So x times x is x squared. Notice the sign. The next sign is minus. And our next term is multiplying a times b. So when I multiply x times 4, I get 4x. Notice your next term has a plus sign, and it says b squared. But remember, instead of saying squaring it, it's going to be easier in the long run if you say, I'm going to take the b and multiply it times itself. So in this case, b is 4, and 4 times 4 is 16. So all you're doing to factor the sum and difference of cubes is to follow the pattern. Okay, let's do another one. So again, I know I've said it a million times, but the first step in all factoring problems is to look for the greatest common factor. Nothing divides into 8x cubed and 1. So we can go on to our next step. So again, we're looking at our exponent 3, which is going to be a clue that we're going to deal with the sum or difference of cubes. Since it's a minus, it's going to be the difference of cubes. So the first step is to decide what times itself 3 times gives us each one of our terms. So I know to get an 8, that's 2 times 2 times 2. And of course, to get an x cubed, it's x times x times x. So that would be our a. To get a 1, it's 1 cubed, because 1 times 1 times 1 gives us 1. And we're going to call that b. So let's follow the formula. So we've done step number 1. Now our first factor is a minus b. Well, a is 2x and b is 1. So why do I have a minus sign in between? Because this started out as a subtraction problem. Next, I just follow my pattern to fill in the trinomial. So the first thing I do is take a and multiply it times itself. So a is 2x. So when I multiply 2x times 2x, I get 4x squared. So my next step, I multiply a times b. What sign do I use? Plus. So the sign I started with, the minus, and this middle sign are always opposite of one another. So my next term is a times b. So a is 2x, b is 1, so 2x times 1 is 2x. My last term is multiplying b times itself. Since b is 1, I multiply 1 times 1, and it gives me 1. This last term is always positive because you're multiplying a value times itself. Next example. First step in all factoring is to remove the greatest common factor. Nothing divides into all of these. So I go to step number 2. I'm going to know that this is possibly the difference of cubes because my exponents are 3. So the first step is I decide what cubed gives me each one of these. So to get a 27, that's 3 times 3 times 3. And an x cubed is x times x times x. To get a 125, that's 5 times 5 times 5. And to get a y cubed, that's y times y times y. So again, I'm going to label these A and B so that I can follow the pattern. So in order to follow the pattern, remember my first factor is A minus B. So A is 3x and B is 5y. Why do I have a minus sign? Because the problem starts out as a subtraction problem. Next, I follow the pattern for my trinomial. So in order to get my first factor, remember it's A times A. So when I multiply 3x times 3x, that gives me 9x squared. My middle sign is always opposite of what I started with. Since I started with subtraction, this is going to be addition. And that term is found by multiplying A times B. So when I multiply 3x times 5y, that gives me 15xy. Again, following the pattern, this is always plus because I'm multiplying a value times itself. So I'm going to take the b, which is 5y, and multiply it times itself. So 5y times 5y is 25y squared. So all the sum and difference of cubes is following that pattern